Welcome to Guided Practice 13. This is problem number 3, and we're going to integrate by partial fractions. If I try to u sub for this, I would u sub for the bottom, and my derivative would be 2x minus 1, and that's not what I have up top, and I can't manipulate it to be that way. So we're going to use partial fractions. I'm going to start by factoring out our denominator. So this is x plus 1 over, hold on, this is supposed to be negative. Negative 12 becomes x, and hopefully on yours it is, minus 4x plus 3 dx. And that means when I split this up using partial fractions, I have x minus 4 in one of them and x plus 3 in the other. And I want a constant term above each one of them. Okay, from there, I've got to figure out my a and b. So I have a over x minus 4 plus b over x plus 3. And that has to be equal to x plus 1 over x minus 4, x plus 3. And so in order to cancel our denominators, we're going to go ahead and multiply everything by x minus 4, x plus 3. And when I do that, we get a times x plus 3 plus b times x minus 4. And that has to equal to x plus 1. Okay, now in the other guided practice videos, you saw me multiply everything out and equate coefficients. And that's totally fine, and that works every single time. But particularly when you're working with all linear terms, there's kind of a shortcut. So this has to work regardless of what number I plug in for x, right? A and b have to be true for any value of x. So I can pick smart choices here. So what happens if I choose x to be negative 3? Well, if I choose x to be negative 3, then this first term goes away, and I just get b times negative 7 equals negative 2. And that tells me that b is going to be negative 2 over negative 7, which is 2 over 7. Awkward, but fine. The other number I want to plug in that will make my life easier is 4. I'll let you think about where those numbers came from. But if I plug in 4, I get 7 times a. The b term goes away, and that's equal to 5. And that tells me that a is equal to 5 over 7. So I get my two values for a and b. From there, we're going to plug them back in over here. So this is equal to the integral of, a was 5 over 7. So 5 over, and I'm going to do this. I'm going to have 5 over 7 times 1 over x minus 4. And plus 2 over 7 times 1 over x plus 3 dx. I'm going to pull the over 7 out front. So this is 5 over x minus 4 and 2 over x plus 3 dx. All right, these are little u substitutions. Okay, so if you sub for x minus 4, you get du equals dx. And if you sub for, and I'm going to call it v just so that it's not the same letter, if you let v equal x plus 3, then dv is just dx, right? So this is 1/7 times the integral of 5 over u du plus the integral of 2 over v dv. And so that gives me 1 over 7 times 5 natural log absolute value of u plus 2 natural log of v plus a constant. And then I just have to plug my u and v back in. So this is 5 over 7 natural log of x minus 4 plus 2 over 7 natural log of x plus 3 plus a constant. And I'm going to leave my answer like that. If you wanted to, this is a big if. If you wanted to, you're allowed to take the numbers out front and put them up as exponents. So that would make this the natural log of x minus 4 to the 5 over 7 plus the natural log of x plus 3 to the 2 over 7 plus c. And then because this is addition, you can put these back together. So this is really just the natural log of x minus 4 to the 5/7 times x plus 3 to the 2/7 plus a constant. But you don't have to do that. Okay, that's just a way that you can kind of simplify and put it back together in a single logarithm. And that's our number 3.